Good afternoon, everyone. I'm Zhuoran from Radboud University, and I will give the overview talk for the pixel privacy task. I think we had a very nice lunch, so some of you may be food coma now. I will start with some very simple examples. Okay, I'll show you some examples of user images on social media. One user posts his image online, and he's very privacy sensitive, so he removed all of the metadata in this image, which means there's, except the image content, nothing is useful is provided in this image. But what he may not know is, based on the image content, geolocation estimation algorithms based on image retrieval can estimate the location of this image where it was taken accurately. So he don't want to share his location with others, but the algorithms can estimate the place, like where the image was taken. What might be worse is if he go far away from his home for a holiday. Criminals has this information may break in his house to get some valuable things. It's bad for burglary. The second example we're gonna talk about is like one user post the image of having fun in a party with his friends, with her friends, and the user just want to share this image with friends. But what this user may not know is, automatic algorithms can easily predict whether the users are drinking, smoking, or like they're feeling happy about drinking and smoking. I guess when the users upload the images, they don't want to share this information with others, but it can be estimated. And Facebook also told advisors it can identify teens feeling insecure and worthless based on the content of the image. Due to tons of reasons like this, we launched the pixel privacy task last year. We have mainly two motivations. First is our images, like social media data, are accumulated online, which means they can be effectively and accurately analyzed by automatic algorithms. The second thing is, I think we should let users have the rights to hide the information that they do not want to share with the companies, with the commercial companies, or with the automatic algorithms, like I showed in example 2. This information might be misappropriated by the commercial companies. So we define our task like this year. We try to increase the image appeal. At the same time, we try to blocking automatic classification of sensitive classes. We simplify the task from a general view of privacy to only sensitive scenes in this year. We offer many information to the participant. For example, the attack model to infer your scene class. Also, we provide our participants image aesthetics score model. It's NIMA here. And we tell all of them how human will evaluate their participant images. We have two criteria. The first is we calculate the drop of accuracy for the attack model. Like if it's lower, means better. You're gonna protect everything well. The second is we have automatic algorithm to give the appeal score of the image. Apart from that, we only have a panel of computer vision expert to give a human evaluation by the eyes, like a human evaluation. And the data we use this year is places standard, and we select 60 sensitive classes. There are classes like places far away from home or in the home, or related to religion, people's health, or like military or security. We select these classes. Here is the gallons of the class bedroom. You can have a look at it to guess like what kind of image the data set has. Compared with last year, this year we use a smaller test set, and all of the prediction for all of the 600 images are 100% right, which means the ground truth label of these images are available. Also, except the automatic aesthetics algorithms in NIMA, we also use human experts to judge your images. And another big difference is we got more teams this year. Like we have 5 teams participated. In detail, we have 9 teams registered, 5 teams submit their working notes paper and submissions. So finally, we got 24 runs for automatic algorithm and 1 run for manual protection. And these are the participant approaches. You can see people use style transfer together with adversarial perturbation. They use image enhancement with adversarial perturbations. Also, like they do this protection in non-salient, non-flat area. They do it in high variance regions, and some of them also proposed a stronger protection compared with the basic version of the method. I will show you the result now, but before that, I want to recap the evaluation metric again. The first is we care about the job of the attack model's accuracy, the top 1 accuracy. Also, we will finally rank it. If you achieve a decrease of accuracy more than 50, then we'll evaluate your image with respect to NEMA score. Like apart from that, we try to make sure all of the aesthetics evaluations went well, so we use a human to do the final check. Yeah. These are the results for the 5 teams, and among them, you can see like there are many runs can achieve the accuracy of the scene prediction model 0, which means it protects perfectly. And with respect to the NEMA score, we have HCMUS texture, which achieved the best score in this evaluation. But something a little bit different happened afterwards. We use human evaluation for these participant images, and we select 10 images with the largest NEMA variance scores in the whole dataset. And for each of them, we follow the rules in this website. And we give all runs to the evaluators and let them pick, for one image, let them pick their most favorite and most disliked ones. These are the good images picked by the human evaluators. The approaches here are enhancement again, or like normal enhancement approach with adversarial perturbations. It means it's a 2-stage approach. People do enhancement first, then add some perturbations on it. We can see mostly the score got increased, but some of them got the score decreased. But we still find these images looks better. Another thing is our like the images got highest NEMA score. They looks like this. So it's not for human being. This is not it's not appealing. So we suspect that it may overfit to the NEMA score for evaluation. But we checked with the participant team yesterday. They said they didn't use anything of it. So something happened. Okay, here are the insights we get from our participant runs. First is protect against top 1 is not enough. For example, if you protect against bedroom, but the new label is bed chamber, it may not help. The second is NEMA is not a consistent aesthetics evaluation metric. As the image you see in the previous slides, the images with highest NEMA score may not occur with human evaluators, and people find it's not appealing. The third is the image structure can be exploited to achieve better visual appeal. And the most frequently used approach is this year is two-stage approach. People enhance the image first, then add perturbations on it. Okay. For the future work, we have 2 lines for organizers and for participant. We will try to get a stronger model to protect against, and which means this will be similar to the practical cases. And we also try to improve the image aesthetics metric, which is NEMA this year, and we found it's not consistent with human evaluation normally. For participant, we instead of the simple 2-stage approach, we expect more creative algorithms. For example, you use the semantic information in this image, or you try to transfer it to some artist style that might be more interesting to evaluate. This is my overview talk. Thanks.